Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our gate courses, you can contact us on these details. Also, you can download Exergic Gate Preparation app from Google Play Store. The link is available in the description of video.
Now let us have a look at this question. The question says that two small spheres A and B with masses 2.5 kg and 1 kg respectively are connected by a rigid rod of negligible mass. So there are two spheres A and B, both of them have different masses. A is 2.5 kg, B is 1 kg. They are connected by a rigid but a massless rod. As you can see in this figure, A and B connected via a rod. The length of the rod is also given to you in the diagram, 210 mm. These two spheres are resting on a horizontal frictionless surface. So both of them are resting on a horizontal surface. This is the top view. So they are resting on a surface, horizontal one, A and B. But when you look at it from the top, this is how it looks, right? When A is suddenly given the velocity 3.5 meter per second along the x direction, positive x. I cap means along the positive x direction. So this direction you have to take as positive x. And it is suddenly given a velocity of 3.5 meter per second in that direction, block A. Question is asking you what will be the velocity of A and B respectively after rod AB has rotated through 180 degrees. This question has 4 options. Answer is to be given in meter per second. I removed the options, as you know, I do it to improve your accuracy for NET questions as well. So try to solve this question. Last line is very important to understand that as a result of this velocity, what is happening? A and B are getting rotated by 180 degree. That's why it is asking you, the velocity of A and B after rod AB has rotated to 180 degree. Solve it. And let me explain it to you if you are unable to solve it. Look, it is very important for you to firstly understand the motion. Don't just try to start solving the question without properly understanding everything. This is the initial condition when A was given a velocity. And after it rotated 180 degree, it is asking you the velocity. So how it is going to rotate? How the motion is going to happen? Firstly, understand that. And solving the question is not a big deal. Look, this AB, they are connected together. The movement of A will be transferred to B as well. There is no friction on the surface on which they are resting. So any effect of velocity will not be stopped, will not be reduced by friction. But how is it going to move? When you push A, will B also start moving in the same direction? Or will A will start rotating like this about B? Or both A and B start rotating about some center? Or both A and B rotate as well as move ahead? Many types of motions are possible. What would be the correct motion? Actually, this can also be asked as a question. Rather than giving this question, I can frame another question where I will just ask you what type of motion they are going to perform when initial velocity is given to A like this. Look, you have given a velocity to A and B as well. Initially, it may seem like that you have only given a velocity to A, but any motion of A will cause the motion of B. It may not cause the motion instantly at that instant, but at the next instant, it is going to be transmitted. The motion is going to be transmitted to B as well. So look at A and B as a combined body for a second. so that I can explain it to you. As such, they are different. Mass of A is different. At initial time, velocity of B is 0, but velocity of A is 3.5. So as such, they are different for our analysis. But for the sake of motion, they will act like a single body, right? Because they are connected. It is not possible that A will start moving somewhere and B will not move. They are connected. So for the sake of motion, they act like a single body. Correct or not? Logical? When A starts moving like this, when a velocity is given to A or to this point in this direction, the overall effect of that on A and B can be understood by finding out their center of gravity. If B was not here, suppose, then what would be the effect of velocity? A will keep moving further because the rod has no mass. Whatever is the mass is concentrated at A. Velocity is given to A, so A will just move forward, right? So for this system of masses A and B, we have assumed a point G between them, which will be their center of gravity, combined center of gravity. A is also a point mass here, B is also a point mass at the center. And let us say that the center of gravity is at a distance of LA from mass A and LB from mass B, right? Now we know that when MA is equal to MB, G will be at the center, means LA will also become equal to LB. And when mass of A increases, as A gets heavier, G starts shifting towards A. So LB starts increasing. So when mass of A increases, LB increases. When mass of B increases, LA will increase because G will shift towards B. So we can write that mass of A divided by mass of B, mass of A divided by mass of B will be equal to LB divided by LA. More will be the mass of A, more will be the mass of A, G will shift towards A, LB will increase. Same can be seen here, right? Direct relation between them. Now in this expression, let us add 1 on both the sides. So you will be having MA plus MB here divided by MB is equal to LA plus LB numerator divided by LA. MA is 2.5 kg, MB is 1. So 2.5 plus 1 is 3.5 divided by MB is 1 kg. 1, right? It is equal to LA plus LB is known to us 210 mm, but let's keep it as L. So L represents LA plus LB here, okay, divided by LA, which is unknown. L is known to us, right? The total length is known to us. LA plus LB is equal to 210. This distance between them is known to us, right? Just keep it L for simplicity. So this will come here, this will become 2, this will become 7. It will give you LA is equal to 2 by 7 times of L. Correct or not? And similarly, LB is equal to L minus LA, means L minus 2L by 7 means 5 by 7 times of total length. This is LA, this is LB. So we have located the center of gravity. You can put the value of L here and you will be able to find out the location of center of gravity. So we have done that. Now what can we do further? Look, center of gravity clearly is not lying at A. Center of gravity is lying at a point other than A. If hypothetically center of gravity was lying at A, exactly at A, then when is it possible? It is possible when the mass of B is not present. And if mass of B is not present, you have only mass of A and the velocity is given directly to the center of gravity, to the center of mass. It will just move in a straight line without any other type of motion, because you have just given a linear velocity to the center of mass. But here the center of mass or center of gravity lies here. The velocity is not given directly to center of gravity, but it is given here at a point which is perpendicular to center of gravity. What will happen as a result of that? If you have a body like this, okay, this point has a velocity in this direction, initial velocity, this is the center of gravity. As a result of this velocity, the body at the center of gravity will have not only a linear velocity but also an angular velocity, because this velocity here can be transferred to the center of gravity with an angular component, right? This is something that we have already discussed in detail. I have told you in the initial units that how do we know the effect of any other force or any other velocity on the complete body, by finding out its effect on the center of gravity. If this is the mass, you give a velocity in this direction, the center of gravity will experience not only a velocity but also an angular velocity. Why? Because this velocity has been given at a perpendicular distance. Let's say this distance is r, that distance is LA, but here let's say that distance is r. So it will be having not only a linear velocity but also an angular velocity, which is given by this expression v by r, right? So in this case, as a result of this initial velocity to A, the combined A and B system will not only have a linear velocity but it will also have an angular velocity. If the velocity was given directly to the center of gravity, then there would have been only velocity. If suppose the velocity v naught, instead of acting here, it was acting at this point, then as a result of this velocity, it will only continue to move further, because about center of gravity, you are not trying to rotate it. But when you give a velocity to this point, then you are not only trying to move it forward, but also you are trying to rotate it about its center of gravity. So the final motion will be a combination of translation as well as the rotation. This is what the type of motion will be for this case. So initially this system looked like this, and after it rotated through 180 degree, this is how it is going to look, right? This was A above. After rotating through 180 degree with translating, A will come below, B will come above. G also will be relocated since G is closer to A. So this is LA, this is LB after rotation of 180 degrees. Now how should we solve the question? We have done enough discussion on type of motion, center of gravity's position, but how exactly are we going to solve this question? Look, the most logical way to solve this question would be to use the funda that I have told you before. In earlier question, one of the earlier question, I told you that whenever you have no clue regarding how to start, just write down what data is given to you. In the question, it has given you just three things rather: mass, velocity, and the distances, right? The distance of points from each other. These three things are known to you. The most logical progression, the most logical approach in this case should be to do something with the momentum. Mass and velocities are given to you, right? I'm just talking in terms of layman. I'm trying to explain this question as if you don't know any concept how to approach the question and you are a beginner. So for this case, mass, velocity, and a length are known to you. Obviously, you have to do something with the momentum since mass and velocities, these two things are given to you, right? Force is not given to you, right? So don't think about finding out some ways to apply any of the other laws. You cannot do it. So applying an equation of momentum seems logical. Second point, look at the question. What is given to you? Some initial velocity is given. Two masses are given and one initial velocity is given. And what question is asking you? The final velocity of those masses. Whenever you get such question, whatever be the setting of mass, the mass may be connected, maybe they are not connected, totally different setup is possible. But whenever you have a setup where you are having two masses, velocities are known to you. Maybe initial velocity of one is known or initial velocity of both is known. But velocities is known and question is asking you the final velocities. Go with the conservation of linear or angular momentum. Mark my words, these will help you, because applying the conservation of momentum is something which many students don't know how to apply, where to apply. They know the this principle of conservation of momentum, nothing difficult. As I told you, in mechanics, expressions are not difficult. Handful of expressions are there, but where and when to apply them is the key. So whenever question gives you some initial velocity, a couple of masses, and is asking you the final velocities, the best way forward in maximum of such questions will be the conservation of linear or angular momentum, or both of them, depending upon the question. In this question, one thing is that question only gave you mass, velocity, length, from which you can calculate either linear momentum or angular momentum. And secondly, the type of question is also similar. Initial velocity, masses are given, final velocity is asked. So applying the law of conservation of momentum is the best way forward in this question. How many velocities you need to find out? Two unknowns, VA and VB, at the final state, at this state. And how many equations you can form by using conservation of momentum? Two. Conservation of linear momentum, conservation of angular momentum, since both translation, linear motion, as well as rotation is happening. So both those equations can be applied. Two equations, two unknown, straightforward question. So even if you are not able to solve it up to this point, I will again recommend you pause the video and try to solve now. You should be able to solve it after this much explanation. I am continuing the discussion. Now, for the sake of applying the conservation of momentum or linear momentum, it is important that you decide the velocities, the direction of velocity. For the initial case, the direction is given to you. For the final case, as I have told you numerous times, that if you don't know the direction of vectors, do not worry, just show them in any direction. Ultimately, the answer will tell you whether your direction was correct or incorrect by the sign. If positive comes as the answer, then whatever direction you assumed is correct. If sign is negative, then your direction has to be opposite of what you have assumed, right or not? So for simplicity, let us assume that at the final state, at this state, both of them are having velocities in positive x direction, in the same direction. And since they are not rotating at a single place, they are translating as well as rotating. So it is very much a feasible situation. If both of them were rotating about the center of gravity like this, then this was not logical, because one will be in this direction, other will be in that direction. But since it is translating also, so it is very much logical to take both of them in the same direction. It is a feasible situation. Now, what is going to be the initial momentum of linear momentum? Let us first talk about linear momentum. Linear momentum. Okay. What is going to be the initial linear momentum? The mass of A multiplied by the given velocity plus mass of B given by its velocity, which is 0. So this term will become 0. So this is initial momentum. Mass of A is 2.5. Velocity is given in that direction as 3.5. So it will come out to be 8.75. 8.75 kg meter per second. Kg meter per second. Right? This is the initial momentum. Similarly, the angular momentum. The angular momentum initially, how much is that? This will also be present only because of mass of A, because velocity of B is 0, right? So MA, velocity of A initially is V0 multiplied by LA. About the center of gravity they are going to rotate, so it will be taken about the center of gravity, right? The rotation. Plus MB, V0, LB. Since velocity of B is 0, so that term I am not writing here. Mass of A is 2.5, V0 is 3.5, and LA we calculated before, and I think it was coming out to be 2 by 7 times of L. I exactly don't remember the expression, but I think 2 by 7 L was LA and 5 by 7 was LB. In this expression, if you put the value of L, which is 0.21 meters, because velocities are in meter, masses are in kg, so this L value will be 0.21 in meter, which is 210. And when you solve this, I think you will get 0.525 kg meter square per second. Kg meter per second multiplied by meter, so kg meter square per second, 0.525 kg meter square per second. This is initial linear momentum, this is initial angular momentum. And from the law of conservation of momentum, for this final condition also, momentum should be conserved, both the linear as well as the angular. So for this case, the linear momentum will be equal to 8.75, and for this case the angular momentum will be equal to 0.525, because momentum, both linear and angular, are conserved when there is no external force or torque acting. In this case, you gave it a velocity, suddenly gave it a velocity as question said, and after that no force or no moment or no torque is applied. So since there is no external force or torque acting after the first point, after the initial point, so from initial to final duration, from this state to this state, momentum, both linear and angular, will be conserved. So the linear momentum will be conserved from initial to final state, means initial momentum, linear one, will be same as final one. Initial is 8.75, final one for this case will be MA VA plus MB VB. Since both of them we have considered in the same direction, and this direction we are taking as positive, so both of them will be positive, right? Both VA and VB are positive, otherwise there would have been a negative sign somewhere, but both of them are acting in the same direction, in the positive. So this is the first equation. You can actually write the values of MA, which is 2.5 VA plus 1 VB. So directly VB you can write. This is your first equation. Similarly, for angular momentum also, the initial value will be same as the final one. Initial one was 0.525, right? And final value of angular momentum will be again taken about this point G. Initial value was also taken about G, MA V0 multiplied by LA. Similarly, final value will be about G, and this value was clockwise. This velocity is going in this direction, clockwise of center of gravity, and that we have taken as positive. So here also positive we will take, clockwise we will take as positive. So whatever angular velocity is going clockwise, positive, anti-clockwise or counterclockwise, negative. VB is going clockwise about G. This is G. This is how it is going, clockwise. So it will be positive, means MB VB multiplied by LB. This part will be positive. And this velocity is counterclockwise about center of gravity, that will be negative, means minus of MA VA LA, right? So this expression, let me write here, 0.525 is equal to MB, which is 1, VB unknown, LB you can calculate from here. This will be 0, it will be 0.15. 0.15. You can do the calculation, a very simple one. Minus MA is 2.5, VA is here, and LA from here it will come out to be, I think, 0.06 and 1.5. All right. So ultimately this will also come out to be 0.15 VA. So 0.15 VB minus 0.15 VA. This is our second equation. So this is equation 1. This is equation number 2. Two equations, two unknown. Solve them, and after solving you will find the value of VA and VB as, this is 1.5 meter per second, this is 5 meter per second. These two answers are your required answers. Both of them are coming out to be positive. It means that the directions that you have assumed are correct. Both of them will be moving in the same direction, and as I told you, it is very much possible because it is not only rotating but also translating. So if translation is fast enough, even with the rotation, net motion will be along this direction only. In rolling, when we will discuss the relationship between them, it will be easier for you to understand it. But obviously, common sense can help you here. It will give you a good idea that if it is moving fast enough, then even if it is rotating, the net velocity will be in the forward direction. This is how you solve such question, and the tip that I gave you in this question will clear your confusion regarding a lot of questions where conservation of momentum is applied. This is such a simple but such a powerful tool, and GATE frequently asks questions on this principle, numericals on this principle. So try more questions like this. I guarantee you, you will not stuck anywhere. If you understood this funda, where to apply, you will not stuck in any of the questions.